So in this episode, we're going to be talking about data protection. So for protecting data stored on EBS volumes, we're going to discuss 3 key components: your EBS encryption for securing your data, EBS snapshots for point-in-time backups, and then AWS Backup for automated data backup. So let's talk about EBS encryption. So AWS has made encryption of EBS volumes as easy as possible. So when a volume is encrypted, all data stored on it is encrypted, and this includes your boot and data volumes. So when you attach an encrypted EBS volume to an EC2 instance, encryption will be extended beyond the stored data to all data transfers to and from the volume. So between the EC2 instance and the EBS volume, that data is going to be encrypted. You encrypt EBS volumes by either enabling encryption when you create a volume, or by using encryption by default. So encryption by default, this is a setting you can configure in your AWS account, and you're going to enforce the encryption on new EBS volumes and snapshots and snapshot copies that you create. So encryption by default, this is a region-specific setting. Once you enable encryption by default, it can't be turned off. So let's have a look at how you're going to actually enable encryption by default. So let's move on over to our AWS console. So from the AWS console, we're going into the EC2 console. And remember, this setting is going to be region specific. So make sure that you're in the correct AWS region for whatever region you need to enable encryption by default. So we scroll over here, we scroll down to account attribution sections, and we're going into the settings for data protection and security. And we're scrolling down to EBS encryption. So you can see here in the Ireland region, I don't have EBS encryption by default enabled. So in order to enable it, what we would do is we'd click on manage, and here we basically would tick this box enable. And from here you can enable the setting, and you would choose whether you want to use the AWS managed KMS key, or if you want to use any custom key that you have created in the KMS service. And once you have enabled it, then you update EBS encryption, and then that setting will be applied to all new EBS volumes or snapshots that you create in that region. It does not affect any previously created EBS resources or snapshots. So just to note, if you do select the default key here, the one with the alias AWS EBS, so if you select the AWS managed KMS key, then you can't share the encrypted volume across accounts. So if you do want to share your encrypted volumes with another account, make sure that you use a custom managed key. So some questions customers have asked me about EBS encryption include, do I need to encrypt my EBS volumes? So ensuring that you encrypt all of your data stored is a best practice. So even if you think there is no value to a potential hacker, encryption by default reduces the chance that someone in your organization may make a mistake. So AWS makes the encryption process very seamless. So this means there isn't any reason not to encrypt your data. So I also get asked, will encryption impact the performance of my EBS volumes? Now AWS handles the encryption process transparently, and you should experience the same IOPS performance between your EC2 and EBS volumes with encryption as without. So even if there was a minor impact during enabling encryption, it's not worth leaving your data unencrypted in the cloud. And the reason for this is because encrypting your data at rest is very important, and it's crucial for several reasons. First of all, security. So encryption ensures that even if someone were to gain unauthorized access to your data, they wouldn't be able to read it without the encryption key. And second of all, compliance. So many industries or customers that we work with have regulations that require data to be encrypted at rest. So encrypting your data helps you meet those compliance requirements. And third of all, privacy. So encryption helps protect sensitive information from being exposed, and this ensures the privacy of your data. So when you create an encrypted volume and attach it to an EC2 instance, the following types of data are encrypted. So data at rest inside the volume is going to be encrypted. Any data moving between your EBS volume and your EC2 instance will be encrypted. So any snapshots created from an encrypted EBS volume are automatically created. Any new EBS volumes created from an encrypted snapshot would also be encrypted. So all of this data that we've just talked about is going to be encrypted once that setting is enabled on your EBS volumes and resources. So as part of data protection, let's talk about EBS snapshots. And these provide you with a simple and secure data protection solution that's designed to protect your data that you store on EBS volumes. So snapshots are a point-in-time copy of your data, and they can be used to enable disaster recovery. They can be used to migrate data across AWS regions or even over to different AWS accounts. And it's basically, with a snapshot, it's going to improve your backup compliance. So EBS snapshots, these are automatically saved to Amazon S3 for long-term retention. So S3 is designed for 11 nines of durability. This ensures higher availability of your EBS snapshots. So as I mentioned, EBS snapshots are point-in-time copies of your EBS volume. When you create that snapshot of a volume, you're backing up that data that's on the volume at that moment in time. So EBS snapshots, they're incremental in nature. So this means that only the data has changed since the last snapshot is backed up to S3. So the first snapshot of any EBS volume is always a full snapshot. So this includes all of the data blocks written to the volume at the time of the snapshot being created. So just to explain the incremental nature of snapshots, let's have a look at this diagram on the slide. So in state 1, snapshot A, this is the very first snapshot of your EBS volume. So this is a full snapshot, so we're backing up the entire 10 gigabytes that's on this volume to S3. So any subsequent snapshots of the same volume are going to be incremental in nature. So we're only going to include the change data or the new blocks that were written to the volume since the last snapshot was created. So for example, in state 2, we still have that 10 gigabytes of data stored on the EBS volume, but we've actually changed 4 gigs. So we've overwritten 4 of the gigabytes and we've changed those. So with snapshot B, as it's incremental in nature, so we're only going to basically back up that new 4 gigabytes to S3. In snapshot B, we're going to reference the unchanged 6 gigabytes and we're going to point to snapshot A that's in S3. And then with state 3, here new data has been added to the volume after snapshot B. So we now have a 12 gigabyte volume in size. So when we create snapshot 3, all we're doing is we're only backing up those 2 new gigabytes to S3, and snapshot C will then reference the 4 gigs from snapshot B, and it's going to reference the 6 gigabytes from snapshot A. So when you delete an EBS snapshot, only the data unique to that snapshot is removed. So any information contained in that snapshot that is required by other snapshot remains available and is not deleted. So if we delete snapshot A, only the data that is unique to snapshot A is removed. As snapshot B and C are still referencing data in snapshot C, that data is still going to be stored on S3, and all other references to any unique data to S2 snapshot A will be deleted. So for volumes created from snapshots, there is a performance hit that you should be aware of. So when you create a new EBS volume from a snapshot, so that new volume, it's going to be an exact replica of the original volume that was used to create the snapshot. When you create an EBS volume from a snapshot, the data has to be loaded into the new replicated volume in the background. You can begin to use this new volume immediately while the EBS volume data loads. But as I've seen from numerous times working with different customers, this is not the best thing to do. So when you create a volume from a snapshot, you need to be aware that those volumes restored from snapshots will not have full performance immediately, as the data is being pulled from S3 where that snapshot is stored. So this is known as lazy loading. So it can lead to higher latency than normal while the data gets loaded, and this can lead to poor user experience for latency sensitive workloads. So, and I see this time and time again with customers. So when they're creating volumes from snapshots, they're not getting the provisioned performance. They're actually seeing very high latency. And the reason for this is when you go to read from the volume, that data is still in S3 and actually needs to be pulled down. So you're going to see latency increasing while we're waiting for that data block to become available on the EBS volume. So to overcome this I/O latency, before putting the volume into production, what you need to do is you need to initialize the volume. Basically, when you initialize the volume, you're going to use a utility in Linux, for example, like FIO. And what FIO will do is it basically pulls down the data blocks from S3 onto the EBS volume. And this initialization process of the volume helps address that I/O latency when you're creating the volume from Snapshot. The volume won't deliver its full performance until it's fully initialized, so all the data blocks have been pulled from S3 and written to EBS. Customers that have large volumes created from snapshots, it can take many hours to pull that data from S3. And a way around this, what I would recommend using is EBS Fast Snapshot Restore, FSR. So FSR enabled snapshots allows volumes to instantly deliver their provision performance, and this eliminates the need for manual initialization and reduces the latency. So another feature of data protection that EBS provides is the Recycle bin. And the Recycle bin is a feature that allows you to recover your EBS snapshots that have been accidentally deleted. So when a snapshot is deleted, instead of being immediately removed, it's moved into this Recycle bin. And you can specify a retention period for the Recycle bin during which you can recover these deleted snapshots. So let's have a look at how we actually would restore an accidentally deleted snapshot. So let's move over to our AWS console. Okay, so here I have an EC2 instance that's running my production WordPress website. So I'm going to go ahead over to the EBS volume and I'm going to create a snapshot in order to back up that data of my production website. So select the volume, go to Actions, Create Snapshot. And we just want to tag that snapshot with a key of name and the value of WordPress. So we can see here that EBS is creating the snapshot. So while it's unavailable and it's pending, the snapshot is still in the background creating. So while we're waiting for the snapshot to finish creating, we're going to go ahead to Recycle bin and set up that bin in order to recover any accidentally deleted snapshots. So as it's mentioned here on the console, in order to protect your snapshots and AMIs, you need to create the retention rule first. So let's give this a name. So I'm going to call it WordPress bin. So I want to, in this Recycle bin, I want to store any of my WordPress snapshots that I've accidentally deleted or need to recover for whatever reason. So with Recycle bin, you can recover EBS snapshots or Amazon machine images, and we're going to recover an EBS snapshot. So you can apply this to all of the resources, so all of the snapshots or all of the Amazon machine images. Or if you don't want to use it for all of your snapshots or AMIs, what you can do is you can apply it to resources with specific tags, which we're going to set here. And we're going to use the tag that we set on that snapshot that's being created. And we need to just click Add there. And then we need to set the retention period. So this is the number of days that we have to recover the snapshot. And I'm going to set this to 10. So from the day that I accidentally delete the snapshot, I have 10 days to recover it. So let's create the retention rule. Okay, and here we see the retention rule has been created. We can see that it's applying to EBS snapshots and it's applying to the snapshots that have this tag. So let's go ahead and test that out. So let's check if our snapshot has created, and it has. Okay, so I've got the snapshot and I've decided that I no longer need it or that I'm going to accidentally delete it. So let's just first of all copy the snapshot ID and check that it has this tag here that we've set on a Recycle bin rule. So go ahead and delete it. Confirm that you still want to delete this. And as you can see here now, the snapshot has been created or deleted, sorry. So in the documentation, AWS will mention it a number of times. It uses a shared responsibility model. So under the shared responsibility model, AWS is responsible for protecting the underlying infrastructure, whereas the customer is responsible for protecting the resources or managing the resources that it applies, such as with EBS volumes, you're responsible for protecting and securing the data. So with EBS volumes, you can protect the data by creating snapshots, but you're also responsible for managing those snapshots that you create. So one way to do this is use the Recycle bin feature. So in this case, we've accidentally deleted it. We do have a Recycle bin set up. So if we move over to our Recycle bin, we should have that snapshot. So to check that, we go into resources and we can see that the snapshot has been stored in the Recycle bin. So as we can see, today is the 13th of August and I do have 10 days in order to recover this. So I can go ahead and recover that now. So just click on recover and confirm that you want to recover the resource. So we're basically restoring the snapshot. So if we go back to snapshots, and we're going to check that EBS Recycle bin is actually putting that back in the snapshots. And we can see here that the snapshot has been recovered. So again, this is one way in order to further protect your EBS resources, is to enable this recycle bin feature. Okay, so finally, as part of data protection, we also have the AWS Backup service. Now, this is a separate service to EBS, but with AWS Backup, it's a fully managed AWS service, and it centralizes and automates the backup of your data across various services, including Amazon EBS. So AWS Backup, it extends your data backup, and it allows you to create backup schedules that you can customize to meet your business and regulatory backup requirements. So with AWS Backup, what you can do is you can set backup retention policies that will automatically retain and expire backups according to your requirements. So AWS Backup, it lets you copy backups across different regions or even across AWS accounts. So in order to use AWS Backup, you need to create a backup plan that defines how to back up your EBS volumes. And the backup plan, this is going to define the backup frequency. So how often you want to basically back up your volume, whether that's daily, weekly, or monthly. So the time window. So at what time during the day you actually want to start the backup. And you're also going to set how long the backup should run. So if the backup should complete in 2 hours, if the backup doesn't complete within those 2 hours, it's actually going to stop, but it's going to start again at the specified backup time that you have in your plan. And then those backups are going to be stored in what's called a backup vault. And the backup vault, this is basically a container to store your backups. So as part of your backup plan, you can optionally create a backup copy into another AWS region, or you can also create a backup plan that's going to move your backups one AWS account to another. So let's have a look at the AWS Backup service and how you can use that. So if we go to our AWS console and we open up AWS Backup, we're just going to have a look at the backups that I have. If you move back, I'm going to set that to Ireland where my backups are. So let's have a look at the AWS Backup service and have a look at one of the plans that I already have in place. Let's have a look at one of the backup plans that I already have in place. So we'll have a look at the WordPress backup plan. And you can see here under backup rules, this basically defines when the backup takes place. So we can see here the frequency is set to daily. And here I've actually set it to 6:05 p.m. Dublin time. So just to know, when you're creating either snapshots or backups through AWS Backup, I would always recommend setting it, don't set it directly on the hour, because a lot of customers will actually set up backups at the same time. And with the EBS architecture, the bandwidth between EBS and S3 is actually shared. So in order to better utilize that bandwidth, so to have your volumes backed up from EBS to S3, I'd actually recommend just basically with the time, just setting a little bit past the hour. This is actually mentioned in one of the EBS documents, which I'm going to drop a link to later on. So here we can see this is a daily backup. And basically this backup, when it's created, it's going to be created for 5 days. And this is basically, so these backups, they're actually going to be sent over to Frankfurt. So I'm copying these backups or cross-region within this AWS account. So if we open up the backup vault in Frankfurt, so we can see here it's in EU Central 1, we can actually see this volume is being backed up every day. And here is all the different snapshots this backup creates.